Everyone, so now we are going to do this COPP. If you see here, COP, configure and verify infrastructure security feature. ACL we already done, we did not done this COPP. So now we are going to do this one. Okay, so now let me show my notes. This one let me show you. So this is a COP, and if you see control plane policy, COPP meaning is control plane policy. Allows your rate limit, like what I can say, example, if you see in the organization, any organization, if you see, they are putting the firewall, they are controlling the data traffic, they are controlling the user. This guy should not open this website, that guy should not open that website. They are controlling all the data, they are controlling all the user, but they are not focusing on the control plane traffic. They are not focusing on the control plane traffic. Example, if any attacker is sending the attack, if any attacker, maybe you have the some router, they are sending lot of ping requests, so your router may go down. If your router is getting lot of ping requests, your router CPU is going to have the they are going to use the more CPU, more resources he is going to utilize, and then at last he will go down. So how we can avoid? By using the control plane policy, we can save or we can secure our device. So what we can say, allow your rate limit traffic that go to the router process. So we can, before going to this one, first of all we need to have the idea about the control plane and the data plane, management plane. Now just remember, now we are discussing about the control plane policy. Control plane policy. In 90% of organization, 80 to 90% of organization, all are looking most of the time data plane. What user is accessing, what user is sending, what user is browsing. They are focusing on that only. They are installing the firewall, allow this user and do not allow this user to access this site. They are controlling the data traffic, data plane traffic, not the control plane traffic. So we need to secure our processor, our CPU of our router. Example, if anyone in your organization, they are sending lot of big ping packet, or they are sending some attack to your gateway will go down. If your gateway will go down by increasing the CPU, you will have the downtime. Okay, so we need to control the control plane traffic also, then only you can secure. So how we can control? We can use the policy, different policy, like saying that if anyone is pinging this many packet, big size packet, drop the traffic. If anyone is sending this many traffic, drop the traffic. We can do that way also. Okay, but before going to the control plane policing, how we can control that one, first of all we should know the plane. If you take router or switch or anything, we have the three plane. We have the three plane. What we have? Control plane and the data plane, and we have the management plane. In simple, control plane means brain, router brain, that is nothing but control plane. Whatever he is processing, like OSPF, EIGRP, whatever process updates all are going, that is a control plane. Data plane is nothing but forwarding our data. Our data is forwarding. Management plane is nothing but, like if you are managing any device by using telnet, SSH, SNMP, that is a management plane. So in all devices we will have the three plane. As we learn in our CCNA level, that each and every device is having the three plane. One is a control plane, that is the brain of the router. Another is a data plane, that responsibility is to forward our data, that plane. And we have the management plane. With that plane we can manage our device, we can access. Okay, so in simple we can say control plane traffic is from device to device. If you are having two router, if this two router is communicating, how they are communicating? With the routing protocol, maybe default route, with the static route, with the dynamic routing protocol. So that one is nothing but device to device. So we can remember like this, traffic from device to device. Control plane traffic is from device to device, is nothing but control plane, whatever traffic is going. Like they are running any routing protocol or anything, whatever the operation, like brain operation, means they are thinking, router is thinking, utilizing the RAM, that is nothing but control plane. Then we have the control plane is like here this router, if anyone is attacker is sending any routing protocol attack on the control plane. They can do some different kind of attacks also. We have the STP poisoning attack, VTP attack, control plane flooding attack. So we have so many attack on the control plane. Okay, now we know what is control plane. Control plane is a what we can say traffic between device to device. And then we will see data plane. Data plane is nothing but data plane is responsible for forwarding the traffic from our user to user. We can say user to user. So this is key point. Data plane is responsible for forwarding traffic from user to user. Okay, if you see this is a user, he is sending some traffic. Here also we can have so many attack. Like this guy MAC address attack, we have DHCP snooping, DHCP or R poisoning attack, we have traffic flooding, authentication. We have so many attack also in the data plane also. Okay, and then we have the management plane. Management plane is nothing but we are going to manage the device, user to device. We can say this is a user to device. Okay, so now we are saying we have three plane. Management plane is user to device. We are accessing the device to configure the device with the help of telnet, SSH or console. And we can say here what I can say, control plane is nothing but device to device communication, and data plane is nothing but user to user communication, and I can say the management plane is nothing but user to device. Okay, in the management plane is also having some attack also, and they can communicate. This is a management plane. How we are managing our device? We can manage our device by using SSH. We can access the router or HTTPS. We can use the TACAC or radius server. With that one also we can communicate. We can use the SNMP, simple network management protocol also. With that one also we can manage. Okay, so this one we have the different best practice we can use to manage this all management plane, data plane, to do that one. But the main concept over here is control plane, this one. Here if you see, this is a COPP, this is the control plane policy. Okay, so but we should have the idea about data plane and the management plane. But now we will see the control plane. So in the control plane, how we can control the traffic, create and enable the control plane policy on the device. So what we can do, we can create and apply the policy, control plane policy on the device. What policy? We can give different policy. Example, I can say this no one can ping with this much size of packet. Example, if you see here, let me show you what we can do. I can take my CMD. Okay, I can ping here. I will write here ping google.com. okay, it is reply is coming. When I say ping, reply is coming. If you see, I am sending the 32 bytes of data to the Google. If I say here, if I send here, maybe I will say 100 bytes of data, it will reply also. Even if I am sending 100 bytes of data, this is 100 bytes of data, he is replying, no problem. But if I send more, maybe I will send big packet, not 100, more than 100 also, then Google is going to drop my packet. He is going to drop my packet. Why? Google is also having the firewall. Before Google, firewall is there. They are saying you want to check only Google is working or not. So why you are sending this much of data? You can check with the small only, this 32 value only. Why you are sending the big big byte you are sending to check the Google is working or not? If you see, now it is a stop. Okay, now let me increase the size again. I will say maybe this much byte, this much bytes of data I am sending to Google. Now Google will not reply. Google is not replying. Google firewall is dropping that packet. Why? Because I am trying to attack on the Google. Which attack I am sending the ping. I am sending denial service attack. I am sending the big packet. So Google can reply me, and he is busy. His processor is busy with replying to me. So this server cannot respond to other. But what firewall is doing? He is denying my request. I will give you a simple example. Imagine you go to any store. Okay, a small store. Imagine maybe you go to a small mini market. Only one guy is there. Okay, only one guy is there. 20 guys go there. All 20 guys go there. They are saying, can you give me any item you are asking? All guys are asking that give me this item, give me this item. That guy go inside and he bring back. And when he come back, you all are move out from the shop, you are leave the shop. He is checking, no one is there. He bring all the item and he check, no one is there. He return back. Again after some time you will go and you will request. And when he bring back, you go away. So this guy is busy with this activity. So this will go down. The other guys, if a new customer is coming, he is not available. He is not reply to them. They are busy with replying to you. So this way what we can do, we can make the server busy by sending the large amount of data. The server will be busy with us, and if other guy is sending any request, he will not respond. So we will have the service down for the particular time. So we can attack by sending the large amount of packets. This is also one of the attack. But if you see Google dropping my attack, when I am sending the when I am checking Google is working or not with a large amount of data, that is how much this is, a I think 10,000 bytes. If I am sending 10,000 bytes, he is not replying because firewall is there. Firewall is dropping that one. Okay, so this way we need to put something in our router also. If anyone is sending any attack, if it is not normal, they are sending heavy data or something, we should deny, else our CPU will go high, our router CPU will go high. So how we can do that way? We have the some procedure. What we will do, we will create the ACL. Why we will create the ACL? To identify the traffic, and we can identify, and when we can create the map, that is class map, to identify the traffic use already created in the ACL. Whatever traffic we selected in the ACL, we will identify that traffic and we will apply the policy. We will say class map, apply the policy in the class map. Whatever traffic we selected, if they are sending the traffic more than this one, drop that one. If it is less than this one, allow them. Like this we can apply the policy, and then we can apply that one. That is a control plane. In the control plane we will apply that policy. Okay, so if you see, this is our lab. Here what we are going to do, we are going to do UDP DOS attack, deny of service, DOS. We can do ping also, ping DOS attack also. What I can say, ping is nothing but protocol which is used for check the connectivity. Same like this also we can do the DOS attack. Like we can send a lot of ping with the high data. So if they have no protection, then the server will go down. The CPU of the server will go high. At last it will go down. So here what we will do, we will have the two router. We will assign the IP address to the router, and we will configure any routing protocol just to exchange the route here. We will have the attacker here. Attacker is going to send the lot of traffic, UDP traffic. We can use UDP, ICMP or DSCP, any traffic we can use, and we will do the DOS attack, deny of service. So the example which I give with the mini supermarket guy, how you are asking him give this, give that, and you are skipping the place. And when he bring back again, when he return the all goods, again you are requesting. So same thing we are doing here, and we are asking this guy pinging with that one, and we are creating the issue with this one. Anyhow we will do, so you will have the idea. So what we are doing UDP DOS attack. From here we can use Kali Linux. From Kali Linux we can do directly the attack. Or we have one more service, that is very small service. It will not consume a lot of RAM also. You can do with Kali Linux, but Kali Linux need the 4 to 8 GB RAM again. So better we can use UDP Unicorn. This is a free application you can download from the internet. With this one we can create the UDP attack. We can create the UDP attack. So what we need to do, we need to put the target IP here, and the port, random port they will generate, and how much the packet size we can increase or decrease, and then we can ping and target and DNS we can run, and then we can attack. So he is going to send the lot of packets about this target, and this target CPU is going to increase. After that we are going to secure this one. How we can secure? We will use the configuration. Which configuration we will do? Just now what I told, we will create the access point. We will select the traffic. We are saying access list extended test. In this access list I am selecting the UDP any traffic, and I am creating the class map. I am giving the class map name is CMap. I am saying match the traffic in the ACL name. I give this name here. I am matching the traffic, and then I am creating the policy map. I am giving the name as a PMap, and I'm calling that CMAP in the PMAP and saying if the traffic is coming 8000, allow, if it is exceed, drop. You can give 8000, 1000, 2000, whatever number you want to give. We are saying if it is exceeding this limit, drop that traffic, and we need to apply in the control plane. We will go inside the control plane, we will apply that policy map input because traffic is going in, and we will apply this one, and we can check show policy map control plane. So here if we type this one, he will say if the traffic is coming the 8000 byte above, we will drop. If it is coming 8000 or less than, they will transmit. So this packet we have the 471, that is a 547 bytes, so that action is transmit, but here it is exceed, so this packet is going to drop. Okay, so we can do this one. How we can do? We can use the GNS3 or EVNG, anything we can use. So I have two router already, I put the topology here. So I will start the router. Here I use the NAT cloud. Okay, you can use NAT cloud. So because this application install in my computer, okay, this application install in my computer, so I need to connect this router to my computer. So how we can connect? We will connect with the NAT cloud. You can get the NAT cloud, this one, from here and drop here and connect here. Okay, so now let's do the configuration. First, basic configuration we will do. So this lab name I will give, this is a control plane policy stop UDP DOS attack. Okay, deny of service attack. So this is a lab name, and now we are going to do the configuration. So configuration is very simple. I will write here first of all R1 configuration, and here enable config T host name R1, and then we will have interface fast Ethernet 0x0. I will write here IP address 192.168.12.1 255.255.255.0, and then we will write no shut. This is the IP I assign in the R1. Now I will do the R2 also. So let me copy and paste this one, same thing what we have here. Here I will paste, and we are going to modify here. So this is R2, this is R2, and here fast Ethernet 0x0 12.2, this will be 12.2, and I will copy this one and I will paste here. And this is the fast Ethernet 1x0. Okay, so fast Ethernet 1x0. So what I will do here, I will get the IP from the DSCP. Okay, IP address DSCP. Let me remove this here. Let me remove, because I want to connect to my laptop. So easy way, I will write DSCP IP address DSCP no shut. If I write this one, I will get the IP from my LAN, what we can say NAT range. If I want to give directly, I can give directly IP also from my NAT range, but this is the best way to get the IP automatically, and we can get. Okay, if you want to check what is my NAT range, we can go here. Example, we are using this. Okay, so this I will go here, edit virtual network editor, and if you go inside this one, it will load. After that you will have here, if you see, this is a VMNet 8, that is a NAT. Okay, and if you see, this is your range 192.168.65.0. if you want to check, click this one, you will see this is your NAT range. Gateway is 192.168.65.0. so I know 65 dot something. So this way I can assign the 65 something, because attacker and this should be in the same network, because this application is present in my laptop. This application is present in my laptop, so I need to have the same network, same range. So with the help of IP DSCP, I can get this IP from automatically from the NAT cloud, and I will get the default route, so I can send the traffic here. Okay, so this way we can do. And this application no need to install, just you download. When you download this application, it look like this, UDP unicorn. Just click and double click here. Okay, no need to install, just double click, it will open like this way, and then we can perform. So let's do here. First of all, I will paste this configuration, and I can run right here OSPF also. Example, just to have the connectivity, what I will do here, even if we did not run the routing protocol, we can do, but anyhow, let me write router OSPF1. Okay, interface fast Ethernet 0x0. IP OSPF 1 area 0. Okay, I enable the OSPF in this interface. Now I will go here, I will enable in this interface. So I will go here, I will enable in only this interface. I did not enable here. Okay, so now let me copy and paste this configuration in the R1 and the other one in the R2, and we will see that. So let me take the console of this one R1, and also let me take the console of R2 also. So let me paste this configuration, so everything is good, no error, nothing. Let me take the console of R2 and let me copy the configuration for the R2. So this is a R2 configuration from here to here. I will copy this, and this is a R2, I will paste in the R2. Okay, I paste here in the R2, everything is good, no issue. Now we need to check what is the IP, because attacker is going to attack the R2. If you see, this is the R2, so we should get the IP here. What IP we get, we should observe here. So we are going to get from the DHCP. I will write show IP interface brief. If you see, I get this IP 192.168.168.65.148. So this is the correct one which I write. So this IP we have the interface. So this is the attacker 192.168.65.1. So this attacker is going to put the target IP here. Okay, and here he is going to start the this what we can say, this IP we need to keep here. If you want to increase the packet size, increase the packet size. Just put this this application is not working, or let me check, he is not able to access. Anyhow, we can send, let me reduce some packet and check. Sometime it is not working, maybe I need to close and start again this application. Okay, so let me close and open, but before doing that one, I will check here show process, show IP process, or show IP. We have one command to check the process also, so I can write here show. Let me check here what is the command we can use, process. Okay, so just I want to check the our process is how much it is utilizing, maybe it is using more or less. There is one command, I think processor or something, show process. Yeah, this command. Which command here? This one. This command we are going to use to check our CPU utilization. This is 1% is utilized here. Okay, so we will use this command to check that one. So again I will check here, only 1% they are using. So now what I can do here, where is that application? Let me open that application and send the traffic. Here the target IP, what is the target IP? I have 192.168. What is that? 165.148, I think 148, or yeah, 148. Now it is working, so now I will attack. Okay, so just close the application and start. If you see, this data is sending with this speed. Okay, attacker is attacking this one. Maybe sometime this application will not work, you need to close and put again. So now we can check the process. Maybe this processor is going to increase. If you see, this CPU processor is using 61. Okay, before how much? Before only 1%. But if you see, when we are sending the attacker is doing the attack here, you will see 61%. Now it will increase also. Maybe this crash and it will go down also if we send more traffic. If you see, now 43%. What I can do, I can increase this packet also. Maybe I can increase this packet. If I increase the packet size, maybe it will go high also. Okay, it will go high. So if you see 43% we have, after some time it will go high. So how we can protect? How we can protect this one means, we can protect by using the COPP, that is control plane policy. So what I can do here, I can stop the attacker now, and let's do the policy here. So let me write here, I will go in the R2 and we will write the configuration for the COPP. Okay, control plane policy. So let me write here the heading. I will write here heading. This one is a control plane policy to stop UDP DOS attack. Okay, so now what we need to do, we need to write IP access list, because with the help of access list we are going to select the traffic. IP access list extended, I am using the extended. We can use anything. I will give the name as test, and here in the extended I will say permit. I am saying permit UDP any. So permit any UDP traffic. So now I am selecting the UDP traffic. Then we need to create the class map. Okay, then we need to write the class map and give any name. I will write the C map. For simplicity I will give the C map. So I created the C map. In that C map I will say match and axis group, and we can say G group, and the name which one we want to match, the ACL name is test here. Okay, so same thing we will say match with that one. Okay, and after that what we can say, we can create the policy map. So what I will do here, I will write here okay, what we can say, I will write here exit, and then we will write the policy map, and then whatever name you want to give you can give. We will give P map. Here for the C map we are giving the C map. Here for the policy P map I am giving the P map. Class map I am writing C map. This name will be where you can give any name. Okay, and then in the policy map I will call the class map. So I will write class and whatever the name of the class map. So I call the class map in the policy map, and I am saying that one, what I will say, police 8000 or any limit we can give. I am saying 8000 confirm. Okay, confirm action will be transmit. If it is exceed, then what we need to do, drop. Exceed action drop, we can say drop. Okay, and then we can exit, and again we can exit, and maybe 3 times, because first to exit from here, we will see exit, then we need to go in the control plane. Okay, control plane. So how we will go, we will write in here control plane, and then we need to apply. So I will apply service policy. We need to put policy, service policy, and input, because traffic is in, and we need to put the P map. So what is the name of P map is this one. So this way we will apply. Okay, so configuration is selecting the traffic here, and calling the traffic in the C map, and in the policy map we are calling this C map and saying this C map, if we have this traffic allow, if exceed drop, and then we will apply in the control plane. That's all. So let me copy and paste and check this one. I think it will work, or maybe if any spelling mistake, anything, we will do again. Okay, so I will go here in the configuration. Now first of all, before going to that one, I will write show process. If you see now 1% only, because we stopped the attack. Okay, now let me go and do that one. So here I will put the configuration. Not this one. Let me copy the configuration from here, the notepad. I will copy this, I will paste here. Okay, so everything is good here. We apply that one. Now if we want to check also, we can check which command we will use. We will use show policy map control plane. Okay, control plane, and we will press here. So if you see here, we are saying that one, if this much 8000 bytes transmit, if it is exceed drop. So if you see transmit nothing, because still we did not send any traffic, and nothing is what we can exceed, nothing exceeds, so nothing is drop here. Okay, but now we are going to generate the attack again. Okay, this guy is sending the traffic. Now we can check the same thing you will have here. If you see here 4 packets, okay, confirm, and this many bytes, and this is exceed, and we drop this one. Okay, if you see again, you will have here, if you see here like this way, you have here they exceed this many, 6 confirm 6 packet, they transmit this one, this many packets exceed, and they will drop this. Okay, action, they drop this many packet exceed and this many bytes, so they drop that one. And if you check here, what we are using command show processor, and if you see, not using that much processor because they are dropping the traffic. They are dropping the traffic. 1% only use and 2%, because if attacker is sending the more attack, it is dropping because we put the control plane policy there. Okay, so this way we can secure our data, means our devices, control plane devices we can secure this way. This is one lab. Okay, what we done here, control plane policy we apply to do the UDP. We can do the same thing for BGP, OSPF. Example, if anyone is doing BGP attack, if anyone is doing the, what we can say, the OSPF attack or any other attack, so we can apply this wherever we want to apply. But for example, we taken the UDP. Let's do one more lab for ping. Okay, someone is sending the more traffic, like Google is dropping us. Same thing we can do, control plane policy, stop ping flooding. We need to stop this ping flooding. So what we can do, we can create the access list, and we will select the ping, and then we will create the map, and then we will match the access list in that one, and we will create the policy map, and in policy map we will call the class map, and we will say if the ping is exceeding the 8000, if it is 8000 or less, then allow. If it is going above, then drop. Then we will say exit, exit, exit. Then we will say control plane, and we will apply in the control plane. So this guy, if he is sending the more ping, that will be drop. Let's do this one, so you will have the idea. So how we will do, in same lab we will do this. Anyhow I stop, right, this attacker. Let me stop because our PC will hang else. So I stop this guy. So in R1 we can do that one. Okay, in R1 we can do this. So what I will do here, this heading we wrote. Okay, so now let me write the other heading. We can I will do that one in the here in the R1. So here I will write the heading control plane policy stop ping flooding or anything we can write. So here is the configuration. Configuration is very simple. What we can do, same thing, IP access list. So I will write IP access list extended, any name we can give as we give test before. So I will write here test, and then I will select the traffic, which one I need to select. Example, I will say permit, okay, ICMP, any. Ping is nothing but ICMP, Internet Control Message Protocol. ICMP full form is Internet Control Message Protocol. So that is a ping. After that, what I will do, I selected here, okay, in the ACL I selected this one. Now I will create the class map. So I will write class map, I can give any name. I will write the C map, you can give any name. In the C map we need to match. I will say match, then axis, group, and we can say name is test, because I am calling that access list in the what I can say class map. After that, what I can say here, I can exit here, okay, exit, and then I will create the policy. So I will write policy map. I can give the P map name, I can give any name. I will create policy map, I will give the name, and then I will write the class map. I will call the class map, whatever the class map name is, C class map name is C map. So I will call that C map, and then we will write here, we will write policy police, any number we can give. I am using the same number 8000, and confirm action. Okay, confirm action, what we need to do, transmit, exceed, what we need to do, exit action will be drop. Okay, so this way we will do an exit, and then we will exit again, and I think 3 times we will exit, and then we will go in the control plane we will go, and the control plane, and then we will write service policy, same command just now what we use. input, and we will give the p map because we are using. If we want to get the log also, we can write the log, but some router is not supporting that one. So anyhow, we will use this one only. Okay, so I will copy this from here to here. I will put in the R1. Okay, but before doing that one, let me ping here. I will say ping, what is the here IP of this one. Let me check, show IP interface brief. So this IP 12.1. So I will ping here 12.1, ping 192.168.12.1. okay, I will say repeat. I can give maybe this many time. Okay, so he is pinging this many traffic is going here. They are pinging, they are sending the attack, and we can increase the size of the packet also. So but now we don't have any configuration, so I am going to configure that one. So let me configure this. Okay, I configure now. So when we have the configuration, suddenly if you see, it is dropping. Before it is pinging, but when we do the configuration, if the traffic exceed, they are dropping. This dot means request timeout. Dot means they are dropping. So if you see, before it is working perfectly, but when we configure this control plane policy, after that it is start dropping the traffic. So here he is dropping. Here wherever you see this dot, the dot symbol, that is dropping. So if you see, it is sending and drop, sending, drop, sending, drop. Like this way we can do. Okay, so what we are saying, we secure, we are saying R1, that is R2 is attacking the R1. Okay, what we can say, R2 is attacking the R1, R2 attacking the R1. And when we configure this policy, what we can say, when we configure this one control plane policy, R1 is secure, R2 cannot attack. Instead of R2, you can think R2 is an attacker. He is attacking your gateway, or maybe your user is attacking your gateway. So this traffic is drop. You can increase the packet size also by writing size something. We can increase the size of the packet also. But anyhow, with this one we verify the traffic is drop. Every, maybe if you see this many ping, we have the drop. This many ping, we have the drop. So this way we can control, we can secure our control plane. Okay, so with this one we cover this COPP, COPP. Okay, this is the, or let me show you this one. If we want to check, we can write this command. Let me go here in the R1 and we can check here how many came and how many drop. Show policy map control plane. Okay, control plane. And if you check here, this 831 packets is confirm, and this many bytes, 49 packets are what we can say exceed, and this many bytes, so we drop that packet. Okay, so this way we can say whatever packets we drop. So this way we can configure and we can control. If you see, this is the drop one, and if I want to stop this one, I can say Control Shift 6 to stop this one, Control Shift and numerical 6 to stop this sending request. Okay, so we finish this control plane policy. Let